Now let's move forward and alright, so now how to connect 7-segment display to MCU. Okay, so connecting to MCU is very easy because anyway you will be having so let's say it's a common cathode display, okay, and this is your MCU, let's say, and your MCU will have lots of GPIOs, isn't it? So you can choose some GPIOs in order to connect that to the 7-segment display. Okay, so you need exactly 1 2 3 4 5 6 7 8 GPIOs from your microcontroller. Okay, if you want to use DP also, okay, otherwise you need 7 GPIOs in order to drive 7 segments of the LED. Okay, and if it is a common cathode, then this must be connected to ground. Okay, that's it. Okay, so there is no much logic in connecting MCU and 7-segment displays. And remember that you have to use the current limiting resistors. Okay, this is a current limiting resistor you have to use in order to guard your LEDs. Okay, and as I said, this is a common cathode display, and the number starts from here, 1. Okay, and if you have common anode 7-segment display, then also everything is same. Okay, there is no difference, but here it must be connected to plus VCC. Okay, this must be connected to plus VCC of, let's say, 3.3 volt. So, and I forgot to tell one thing here. Okay, common cathode, what happens is, since all the cathodes are tied to ground, okay, if you make this pin high, LED glows. Okay, that means LED also goes high. And if you make this pin low, okay, then LED goes low. But this is not the case in common anode. So in common anode it is different, right? So since all the anodes are tied, okay, if you make this pin high, then LED will go low. Okay, and if you make this terminal low, okay, then this LED will go high. That means if you connect this to GPIO, okay, of your MCU, then okay, if you drive that GPIO high, then the LED will go low. Okay, and if you drive that GPIO low, then your LED goes high. So both the operation are inverted here. Alright, so I hope you understand that. Now let's move forward and let's understand how to connect 7-segment display to Beaglebone black hardware. The BBB GPIOs can only source 6 to 8 milliamps. Okay, this I have told you several times. Okay, that means the GPIOs, okay, which you can locate in the expansion header, they can only source 6 to 8 milliamps of current when in output mode. So if, for example, the LED's maximum forward current is 20 milliamps, then need not to use any current limiting resistor. Okay, this I have explained several times. Okay, because the LEDs will have forward current in the range of 15 milliamps. Okay, so but the BBB GPIO sources only 6 to 8 milliamps, so it is far less than the maximum rating, right? So then you can skip connecting the current limiting resistor. Okay, in most of the cases when you use different hardwares, you may not be knowing this value. Okay, in that case skipping the current limiting resistor will be dangerous. Okay, but in this case I will skip the current limiting resistor. Okay, now let's move forward. Okay, so now how to connect 7-segment display to the Beaglebone black hardware. Okay, as I said, you have to use some pins, okay, from the expansion header, okay, in order to connect that to 7-segment display. Okay, so including decimal point, we need 8 pins from the expansion header. So I have chosen these pins, okay, from the P8 header. So this is actually a common cathode display. Okay, so you can connect this to expansion header 9, pin number 0. So that's the ground point. Okay, great. So the connection is very simple. I'll give you an example. So here expansion header P8 12 pin is connected to first pin of the 7 segment display. That means this pin. Okay, this is a first pin. Okay, so that happens to be the segment E. Okay, so like that. So and between P8, so when I connect P812 and this pin, so I don't connect any resistor, but if you connect resistor, then also it's fine. Okay, and P811 is connected to a second pin of the 7 segment display, that happens to be D. Okay, so like that you have to finish the connection. Okay, and if you have common anode, okay, then also connection is same. So only thing is you have to connect this common point to plus VCC. Okay, so but you have to connect it through a resistor. Okay, so don't connect directly this pin to VCC. Okay, so that is VCC means here 3.3 volt. Okay, so that you can drive from P9 3. So the P9 3 actually gives you 3.3 volt. Okay, don't connect directly, you can use the resistor in the range of, let's say, 330 ohm. Okay, and rest of the connections are same. Great. So now creating digits. Okay, so now let's see how we can create digits on the 7 segment display. So I am just considering a common cathode 7 segment display. Okay, so let's say I have to display 0 on this 7 segment display. I have to turn this one, this one. Okay, so all these segments on, right? So I have to turn this off, right? So how to do that? Okay, so that means what you have to do is you have to turn on segment A, means okay, you have to pull this GPIO, okay, to high, right? And B means okay, this one. Okay, so this you have to pull high. So like that you have to do. And the G segment, okay, that means this one, P816 has to be pulled to low. Okay, so like that you have to handle these GPIOs. Okay, so in order to display digits. Okay, let's say I have to display 1, then I have to pull B and C high. Okay, so that means I have to pull this one, okay, and C, this one, okay, as high, and rest of the GPIOs must be pulled to low. Okay, we'll see how we can do this using our C application. Okay, so by driving appropriate GPIOs to high or low, so you can print up to 0 to 9. Alright, so I hope you understood the concept, and don't worry, okay, while we do the coding, you'll understand more. Okay, so in the next lecture we will implement a software to display the up-down counter on this 7 segment display by interfacing with the Beaglebone Black hardware. Okay, so I'll see you in the next lecture for the coding part.